Okay, so our next shape that we're going to take a look at, the area formula, is also another quadrilateral, right? This time we're going to take a look at a parallelogram. All right, now a parallelogram is a quadrilateral, right? So it has four sides. So a quadrilateral where opposite sides are parallel. Okay. All right. So you might be thinking, well, didn't we just do that in the previous video with rectangles? Well, remember that the rectangle had the additional property that all angles were 90-degree angles. This excuse me, right? This figure does not have that condition, right? So an example like this would be an example of a parallelogram, right? Think of almost like a rectangle that's kind of leaning, right? It has the base, but it kind of leans, right? So we could say, though, right, that rectangles, right, are parallelograms. Oops, excuse me, right? Opposite sides being parallel. Okay, so opposite sides are parallel, and through kind of triangle congruency, we can prove, and again, we won't go through the proofs here, but the diagonal angles are going to be congruent. So this angle would be congruent to this angle, right? This angle here, the diagonal one would be this one here. They're congruent. And then opposite sides would also be congruent. So so this side congruent to this side here, and then this side congruent to that side there, right? So opposite sides not only are they parallel, but they will also be congruent. Okay, so those are some properties of the parallelogram, right? Even though the strict definition is just that the opposite sides are parallel, all these other properties, they kind of can be proven with triangle congruence. Excuse me. See, but we won't be doing that here in this video. Okay, what we are interested in is, well, how do I find the area of such a thing? Right now here, remember the area is how many unit squares we can fit here. Now, once it's kind of leaning like this, when the angles are not 90, right, we can't really think of like length and width like the unit squares here. But we could take almost like a similar type approach here, right? So here, let me draw a bigger parallelogram here, right? So to kind of see what the area formula is going to be. Okay. So let's say we had this parallelogram, right? And I'm going to define the height of a parallelogram to be from one of the corners to drop a perpendicular straight down here. So this makes a 90-degree angle here. So this is what I'll determine to be the height, right? So I can think of it like this here as almost like the base of the parallelogram, right? And the height of the parallelogram would be from the opposite corner there, dropping a perpendicular down to the base. All right, now if I kind of envision here, almost like I want to fill out this parallelogram into a rectangle where, let's say I drop and I extend the base here, right? All right, so this here is going to be h as well, right? Just so you can see that from the figure. And here I have another right triangle. As it turns out, right, these two triangles here, this red kind of dashed one and this one created here, those are going to be congruent, right? Because they share, it's a right triangle, so they share the same, right, hypotenuse, right? Again, properties of the parallelogram. Those sides are congruent. And so the hypotenuse is congruent, and so is one of the legs. That is actually enough to tell me that the triangles are, both of those are congruent, right? So that means that this here, this length is the same as this length here. Right, and why that's important, because once I do this, right, so that means that the area of this triangle here is going to be the same as this dashed one here. Well, if I look at the overall bigger figure from on the left here, the dashed H here across here, well, now that's a rectangle, right? All these angles are 90 degrees, right? And I know the formula of a rectangle, right? It's length times width, right? In this case, the length is going to be the base, right? Because from here to here is going to be B. Now here, the width, it's not the length of the side, but this height H, the height of the parallelogram, right? So as it turns out, our area formula for a parallelogram area is B for what I call the base, and H what I call the height. All right, so we do use the area of the idea of the area of rectangle, but it's just we do a little different different steps to kind of get us to this base times height. Okay.